So the final piece of the puzzle we're going to cover tonight in the context of the Math Services app case study is the implementation and the performance of the test driver. And that's really what sets all the wheels in motion. And it's what is used to, it's going to call the various methods in the MathServicesClient class, and it uses them to communicate with the microservices, and it prints the results that come back. And the test driver is going to apply the Java structured task scope concurrency model. So again, that's in the EX3 project in the web MVC folder in my live lessons GitHub repository. So here we are with the final piece of the puzzle in the EX3 repository. And what we're going to take a look here is the Math Services driver. And the thing to note here is that unlike the previous examples we've looked at, this is not a Spring Boot test. This is a Spring Boot application because we have two microservices, and Spring Boot tests seem to only work with one at a time. So we had to do something a little bit more interesting. So I'll show you how to run this in a second. You should also notice that the Math Services driver implements the command line runner. Command line runner is an interface defined in Spring that basically allows a Spring application to emulate a command line application. And you'll see how that works here in just a second. We're going to auto wire the test client to be the Math Services client, which of course it gets over here from the client folder. And then the main entry point to this program does something similar to what we've seen before. We parse any command line arguments because this is a command line runner. And then we go ahead and we run the application, passing in the Math Services driver class. And what happens when this occurs with a command line runner is it ends up calling this run hook method, which you can override in order to emulate the command line. And so what we're going to do is we're going to print out that we're entering the Math Services driver main. Really should be run, but it's the main part. Maybe I should say run. And then we're going to go ahead and parse any command line options. Once again, I guess I probably don't need to do that twice. I can get rid of that one. And because we're going to do it down here. And then we go ahead and we generate a bunch of random integers using a technique we've shown many times before. We make ourselves a stream of count random numbers between this lower bound and this upper bound. We box each of those primitive ints to be reference integer types, and then we turn them into a list. So we've got a list of random integers. And then we call the run tests method. And what the run test method does is it takes that list of random integers and it defines two local variables, both of which are futures to lists. So one of them is the futures to the lists of prime check futures, and the other is going to be a future to the list of GCD complete futures. And I should actually call these future because it's not futures. There's just one of them. And then down here, we come into the try with resources block where we're going to make ourselves a new structured concurrency, structured task scope of type shutdown on failure, which is that, nested subclass of structured task scope, which will fail if anything fails. So it shuts down on failure, but if everything succeeds, we get all the results back when we're done. So we then go ahead and we fork off two virtual threads, one of which is going to run the check primalities method. So it's going to make that call to the the primalities microservice in parallel with this call to the GCD microservice. So we're going to check the primalities in parallel with checking and computing the GCDs. Both of those give us back futures. We then use the join method, which, as you know, is a barrier synchronizer that waits for everything to finish, both of those tasks to finish, or it'll throw an exception if things go awry. So we kind of daisy chain these together using a fluent interface style of programming. And then if we get to this point, everything's gone right. And now we're going to display the results. So we take the results of each future, which are done now because we wouldn't return from join if not, and we print out the results. And if it all goes well, we exit the command line runner gracefully. Otherwise, if an exception has occurred, we basically print out an exception. And we probably should say system exit 1 or something like that to indicate that it failed. Okay, so let's go ahead and run this thing, and you can see what it actually does. So if we come up here to the top and we get zoom out of the way, we go ahead and run our microservices. So this is going to go ahead and start both microservices. It's a little multi-run script, which will compile the code. And you can see what it's doing here. It's up there. compiling all the code because I made some changes since I found things that could be improved. So once that's done compiling, then it'll go ahead and be ready for the client to start after it starts both microservices. So both microservices are now up and running, and you can see they print out some information here. You can find out what ports they're listening on. For example, you can see the GCD application listening on port 881, the primality application is listening on port 882. And now that these are both up and running, we go ahead and crank up the MathServices driver. That also runs as a Spring application, but remember, it's a command line runner, so it's going to behave like you would expect if you were running this from the command line. And I disabled a bunch of the diagnostic messages, so it would just mostly be the results. It's a little bit less convoluted. But you can see what's happening here. This is basically printing the results out. This is also just printing out the URL that has all the requests to the primality service. And you can see these are all the results that are the results of the prime number computation. So for each prime candidate, we find out what its smallest factor is. Anytime it's 0, it means it was prime. You can see there was one prime number there, actually a couple prime numbers. And then down here, you can see the results we get back from doing the GCD computations. And you can see we have, for each pair of integers, we get back the GCD of those pair of integers. And so that's basically just kind of running everything that we'd expect to have here. And if we go look over at our code here, you can see that everything worked, which is nice. We want it to work. And we also printed out some diagnostics, and you can see that everything worked on the server side as well. So that's basically the walkthrough that I wanted to do of this application. Hopefully you have a better idea now of how you can combine different concurrency models using Spring Web MVC. You can have the client have one model. You can have different microservices have different models. And this example also demonstrated how you can have multiple microservices. Keep in mind, as I talked about before, that the next example we're going to look at will be a much more production grade style, where we're actually going to have something called an API gateway, and it's going to hide the existence of multiple microservices behind a pretty much automatically generated router, which is really cool. But that comes next.